to the cloud. There we go. All right. So welcome everyone to another one of our docent enrichments. Really excited to have you here, and especially excited for Emma. And we're gonna learn all about her thesis. You of course all know Emma, best co-worker ever, especially here at Año Nuevo. So really glad, and I think we're really lucky to have her and her knowledge. So I'm just gonna have you take it over, Emma.
Okay, if anybody has any questions, feel free to pop those in the chat if you just want to make sure that they stay in your brain, or write them down. If there's anything that's confusing throughout the talk, feel free to interrupt me so I explain it better. But if you've got some questions that you think might take a little bit more time, maybe we'll save those till the end. Sound good?
Yeah, that's what we usually do. Is people have been putting things in the chat, and then at either some point you can say, hey, got any questions, or at the end we go through and answer them all. So however you want to do it.
Yeah, let's wait for major questions till the end, but if anybody feels like they're totally lost on something that I'm saying, feel free to unmute and stop me. But I'm gonna try my best to not do that. Okay. Let's see. Can you guys just see the slide screen, or are you seeing presenter view?
We're seeing your main screen and also a bunch of thumbnail pages at the bottom.
Don't want that. I swear every time I do this, I always forget how to make that work.
Not a problem. We still have people coming in, so. I mean, if you end up having them on the bottom, that won't be a horrible thing, but.
No, I'd rather you guys not have to look at all that. I can do it from my brain too.
There you go. Now there's not, well, there's the ones on the, there.
Just the slides?
Yep, just the slides.
All right, I'm doing it from memory, so bear with me. All right, everybody can hear me? Cool. So I'll make that small. So thank you guys for coming tonight. I'm excited to share my graduate research with you guys. I know a couple people have already read my thesis, so you probably already have some preface to what I'm going to talk about tonight. But what we're going to focus on tonight is northern elephant seal colony establishment and growth in the King Range National Conservation Area. So to start out with an outline, I'm going to go over northern elephant seal population biology and their natural history to start. My thesis was broken up into 2 chapters. So chapter 1 is very brief colony description in the introduction. And then everything else I'm going to talk about in regards to results is going to be my 2nd chapter, which is going to focus more on how does a colony form and who are the main players in that. So this is something all of you are very familiar with. In a little bit different of a format, it's not a circle, so bear with me. But in general, elephant seals are spending a vast majority of their time at sea. So when they're on land, it's a very short window of time that we're seeing them. But when they are on land, they're separating out their seasons based on how old they are and what sex they are. So when we're thinking of when pups and weanlings are on the beach, they're here from about mid to late December through to May, when they'll leave for their first feeding trip as a weanling. Juveniles, and these different colored yellow bars indicate kind of a high abundance period in the darker yellow, and kind of this weird here but shouldn't be here lighter yellow bar. So juveniles could be observed on a colony any time of the year, but the vast majority should be here during their spring molting season, and then during the fall resting haul out, which is taking off right now at Año Nuevo. Adult females, primarily on the beach during a concentrated window of time during breeding season. We might have some females that either didn't breed during breeding season or a little bit late to wean their pup that are around in March and April. And then most of those females will be back present on the colony in late April and May for their molting season. And then our subadult males present for breeding season. And then most of them have probably head out to sea. I know there's still a couple out there finishing up their molt this summer. So when we go back to northern elephant seals population history, as we all know, extremely bottleneck species. These animals, thankfully, survived very intense hunting during the 1800s. The few remaining survived on Isla de Guadalupe. And in 1922, the Mexican government deemed this island a biological reserve. And it's really to their effort that we have elephant seals here throughout their range today. So what I'm gonna do here is show you an animation of, from this small amount of seals that was left on Isla de Guadalupe, how did they radiate back through their historic range as they recolonized after that implementation of protection. So in the 1930s, Islas de San Benito was colonized in Mexico. In the 1950s, northern elephant seals expanded up to the Channel Islands. In the 1960s, they colonized Año Nuevo Island. And then you're going to see throughout this that there are still some colonies forming kind of below where the northern movement is occurring. So there's fill-in as colonies still occur to the north. In the 1970s, we see the Farallon Islands colonized and the first mainland colony site, Año Nuevo mainland. Very important. Historically, we thought that these animals were primarily island breeders. So them colonizing the mainland could be a shift in how these animals utilize habitat and increasing their habitat overall during this recolonization process. In the 1980s, moving up to Point Reyes, and additionally jumping up to a site called Castle Rock, just on the edge of Northern California. In the 1990s, Piedras Blancas was colonized, and then they moved up into Oregon to a small island offshore. 2000s, they colonized a few small islands up in the Strait of San Juan de Fuca, one of which being on the British Columbia side. And then bringing us to our most recent colonizations in the 2010s, the King Range National Conservation Area that we're focusing on this talk, and Vandenberg Air Force Base down near Point Conception. So these are the major colonies that we see elephant seals at today. Not to say that there won't be more. But these colonies really vary in size and growth status. So what we're seeing throughout their range is some are increasing, some are stable, some are decreasing. Año Nuevo is an example of a stable colony. But the King Range, and this line here is indicating what has been described as their historic range, although we're not 100% sure if it actually is, because their archaeological record is not very vast or descriptive. As we know, most of these animals pass away at sea, so there's not a lot of evidence of where they were on land. But what has been said to be their historic range is Point Reyes. So what we're really seeing is the King Range is the only really growing colony north of Point Reyes, north of that potential historic range, because these other colonies in Oregon, Washington, and British Columbia over the last 20 or so years really haven't taken off. And that's partially because they're pretty small island habitat, and because they're heavily impacted by winter storm activity. So the King Range could be this potential new growing large colony that kind of helps the population as the climate changes in the future. So going back to whatever data I could potentially find before I started on this study, the first document I could find of an elephant seal at the King Range was in 2011. And that specific individual was a juvenile, or more specifically a yearling. So an animal that was in its first year of life. The first pup was observed in 2015. And this specific long-term monitoring site by Cal Poly Humboldt started in November of 2017. So what have we seen so far? So this is giving you 4 years of data. And we're looking at this from essentially the end of the summer through to the next summer. So we're seeing there's 3 distinct peaks for elephant seals at the King Range, and this is very similar to other colonies where juveniles have a very large presence in the fall. During breeding season, there are very high peaks with that presence of adults and pups being born. And then the spring molting season is our highest abundance of animals due to a combination of adult females and juveniles being on the beach. And then very similar to summertime, there's not a lot going on in the King Range either, only about 40 animals. So what we want to really pay attention to in this figure is if we're looking at the peaks during breeding season, they're increasing every single year. And me briefly looking at the new data for this year, we also saw an increase this year too. So this colony is growing over time, and it's showing no signs of slowing down. Pup production also has been increasing over time. This dotted line here is indicating when our data collection started. So we did have rough counts before that from some of the locals that were watching the seals out there. And they're just continuing to give birth to more pups every year. The 2022 data showed a significant increase as well. So this colony is continuing to grow over time. If we take one of those years and break that line down into age groups, this is what we see. So in the fall, vast majority rule is juveniles. Breeding season, obviously we're seeing pups turning into weanlings, adult females, and the subadult and adult males present. And then in the springtime, that spring cohort of seals is mostly juveniles, with a decent percentage being adult females as well. So if we're looking at this and saying what seals are really utilizing this colony right now, the vast majority are juveniles. So they're playing a really important role in this site being useful for elephant seals, but potentially useful for them as they turn into adults. And then, you know, we're all excited when we see a flipper tag. So who's coming to the King Range? You know, we have pups being born that we are tagging, but if we're just looking at the seals that are immigrants to this area, the majority are coming from Point Reyes, with also a significant portion coming from Año Nuevo. We do also have seals continually coming from Piedras Blancas as well. And then this 1% here includes the Farallon Islands, Cape San Martin, which is Big Sur, and San Miguel Island. So most of these seals are coming from the closest, largest colonies to recruit at this new site. So since we talked about juveniles being important and how does a new colony form, let's talk about dispersal. So these new colonies form through the movement of an individual from its birthplace to a potential breeding site. So all animals disperse, and many colonial breeders disperse for a variety of reasons. So this little furry guy called the proboscis bat is a colonial breeder that mainly disperses away from its natal breeding site because it's trying to avoid inbreeding. New Zealand fur seals primarily disperse away from their site because of mate competition. And then thick-billed murres primarily disperse away from their natal breeding site because of resource competition. So there's a lot of different factors. But when we're looking at dispersal in these animals, there's many different reasons to disperse, but is it the young animals that are dispersing, or is it the adult animals that are dispersing? So dispersal happens in two ways. Natal being the movement of a juvenile away from its birthplace for its first breeding attempt somewhere else. Whereas breeding dispersal is the dispersal of a mature animal moving from a place where it has already bred to the next season going to a new place to breed. So we see in all of these species that I show you here, primarily driven by natal dispersal. So the juveniles are the ones moving away. And then if we look specifically at pinnipeds, seals, sea lions, fur seals, natal dispersal is the driver here. And we see potentially a male bias. Not to say that females don't also disperse, but more males disperse than females. Or there's no sex bias and both disperse at the same rate. But that dispersal event can happen kind of over a short distance or a long distance. So when we talk about prospecting dispersal, we're talking about this long kind of exploratory movement away from your natal site. You have to put effort into going that far away. Whereas spillover dispersal could be, you happen upon the next rock, the next beach. So a good example of spillover dispersal would be going from Año Nuevo Island, where it's highly impacted, lots of seals, to those few seals that transitioned over to the mainland for the first breeding attempt. So the objectives of the second chapter that's going to focus on how did this colony start and how is it developing are going to focus on, one, determining the age and sex of both seals that were born there, natal seals, and seals dispersing to the King Range, and focusing on juveniles. And I apologize, you might hear my puppy in the background right now. Two, describe the peak abundance, arrival date, tenure of each age group of juveniles at the King Range during both of their seasons. So because we're interested in these juveniles that are likely the ones forming this new colony, how do they use that colony when they get there? And how is that going to impact their recruitment there as an adult? And then three, examine and categorize the movements of both those natal King Range juveniles and the dispersing immigrant juveniles to and from the King Range colony. Do they head straight there and that's where they go and that's where they always go? Or do they test out a couple different sites before they decide that the King Range is their new home on land? So very similar to how you see data collected out in the field at Año Nuevo. We went out and looked for all flipper tags we could possibly find. either weekly or bi-monthly. This is definitely not the most easily accessible site. I had to drive 2.5 hours both ways to get to this field site, whereas students at UC Santa Cruz are very lucky to only have 30 minutes in both directions. But this site is very unique in the fact that when you look out at all the colors of tags, it's not just one color like it is at Año, or not the overwhelming majority is green. This site is very much a plethora of different colors. We also marked animals, very similar, actually in the exact same way that they do at Año. So there are lots of seals out here that look like they're tattooed. It's a very different site where there isn't an educational tool to tell people, except for the 1 day a week I'm out there, why the seal has a number on its side. So this site is really benefiting more now from more educational tools. And then lastly, tagging the pups that are born. Thankfully, this colony is very small. At most, you have a little under or around 240 seals at most to tag that are pups, which isn't nearly as many as they tag every year on Año Nuevo. So it's manageable to hopefully tag every single pup that's born and that weans. And the king range seals specifically are getting blue tags. There is one other site in California that also puts out this color. So if you ever see one of these at Año Nuevo, let myself or Patrick know and we'll figure out where it came from. So using all of these techniques, we can gain an understanding of who are these seals, how old are they, and where did they come from? And how long are they staying on the beach during those seasons? So looking at those juveniles, the juvenile age group ranges potentially up to 3 to 5 years old for elephant seals. So we wanted to really look at each age individually within each season to see if there's any differences between a seal that was born that year versus a 2-year-old. Are they doing different things on the beach? Do they use a colony differently? Do they disperse at different ages? So here I'm going to try and define those ages very clearly so that the results of my thesis make a little bit more sense. So year 1 of a seal's life, they are weaned from their mom, and then they head out. That blue, dark blue bar on the bottom is a feeding trip. So they head out on their first feeding trip. They come back onto shore for that coral colored first fall resting haul out, and they'll head out on their second feeding trip. So that whole time span, or at least that first feeding trip to resting haul out, we're labeling them as age 0. So they're within their first year, but for that chunk, they're age 0. When they come back on the beach for their first adult molting season, they're going to be labeled as age 1. And these colored boxes around the seasons are going to match up with the colors that I use in the results. So within each year of life, these juveniles have 2 dispersal opportunities. So during those 2 feeding seasons, at the end of that, they can make an active choice to either go back to where they were born or go somewhere else. Very similarly, we're going to repeat that process into year 2, but their age is going to change. So after that first adult molting season, they go to sea, they come back for their second resting haul out. At that point, they're still labeled as age 1. They go out again to sea, and for their second adult molting season, they're labeled age 2. Same thing, 2 dispersal opportunities. Year 3, their third resting haul out, they'll be labeled as age 2 because they haven't yet hit age 3. But by the time they come back for their third adult spring molting season, they're age 3. and again, 2 dispersal opportunities during that time window. So these young animals that are not mature yet have a lot of opportunities to pop around to different places to see if they want to change where they're eventually going to breed as an adult. So looking at my first objective, the age of first observation of seals at the King Range. So we're using those same terms of within their first year, those different ages affiliated with each season. And we're looking at seals, natal juveniles who are born at the King Range that are then returning. We have 77 of those documented so far. And looking at dispersing juveniles, where we have 231 that we're able to look into their histories. So is there any difference in a seal returning to its site where it was born or dispersing to a new site? So when we're looking at this data, and these just give you a visual of the size difference between those animals. What we found is the vast majority of these animals are either returning to their natal site or dispersing to a new site within their first year of life. So that first year is a really key time for these animals to explore and move around. Additionally, this 63% of these dispersing animals, that's occurring right after during their first opportunity to disperse. So most of these juveniles are exploring right away. Hold on one second. They're exploring new habitats right away. And that first year is still very important overall. So when we're thinking about, okay, that first year is really important, and these animals are obviously doing different things based on their age, how are they using a colony once they disperse to it? So we looked at the 2 different seasons, and this is just showing you on a given day how many 0, 1, 2, or 1, 2, and 3-year-olds are on the beach at the King Range. So if we're looking at these 2 different seasons, you can see that there's obvious differences in that during the fall, dependent on your age, you're on the colony at different times of year, or you're peaking in abundance at different times of year. Whereas in the spring, you're peaking in abundance at the fairly same time. So in the spring, it's a much more concentrated window of time, about 3.5 months. Whereas the fall, the juveniles have a lot longer of time, about 5 months. But as we all know, the spring season has this physiological intense process of molting, and that demands them to be on the beach for a specific amount of time. Whereas in the fall, we're still trying to figure out what the real reason is for them coming back to shore. So we've looked at it in a general sense of when is each age group on the beach. Now we're going to look at these juveniles as individuals. So what is each individual at age 0 to 3? When are they choosing to arrive to the beach during those respective seasons? So bear with me, this is a sciencey plot. We have age on the x-axis and Julian calendar arrival date on the y-axis. If you're not familiar with Julian date, instead of having like January 15th, it's just labeling that as date 15. So it's a scale of 1 to 365 or 366. So it makes it a little bit easier to plug the data in. But when we're looking at these box and whisker plots, the bar in the middle of the box is where most of the data points are falling. Those whiskers coming off the box and those dots on the outside are kind of the outlier data points or the spread of that data. So what you can see here is the arrival date matches up pretty well with that last plot of, juveniles in the spring are arriving at a fairly similar time, whereas juveniles in the fall are separating based on their age when they're coming to the beach. Why this is? Good question. We'll get into that a little bit further. So we looked at when do they get on the beach, but now let's look at when or how long they stay on the beach. So I defined tenure as the number of days from the arrival date to the last day they were seen during that season. So same plot, very different in the sense that the y-axis is tenure and number of days. Age on the x-axis is the same. So if we look at where those median bars are falling for the fall, the juveniles are spending less time overall, if you're looking at the majority of them, on the beach in the fall versus the spring. So the time can be any time during the season, but it's a lot shorter, whereas the time has to be very concentrated during the spring, but much longer. But we do see, specifically in the younger age groups, a lot of variability. So if we're looking at age 0 and 1 in the fall and age 1 in the spring, those young seals haven't really figured out what their plan is yet. So we're going to look into that a little bit further on the next slide. So because there was so much variability, I wanted to further categorize what those seals were doing. So they fit into 3 different bins for attendance patterns. It was either single sighting, where a juvenile was observed on the colony during one survey within a season. A single bout, which was a juvenile observed over multiple surveys with an estimated tenure of 2 to 49 days. So they came to the beach, they hung out on the beach for 2 weeks, and then they left the beach. Double bout is a juvenile observed over multiple surveys during 2 distinct periods with a greater than 6-week gap between sightings in one season. Lots of words there. Essentially, that means that a seal could have been seen for 6 days in September. It disappeared, and then we saw it for a week in November. I doubt that we missed that seal in between, and there's no way that seal spent that whole amount of time as a juvenile on the beach. So likely it came to the colony twice within a season. So essentially spending time on land 3 times out of the year rather than just 2. So looking at that data, what we found was during the fall season, there's a lot of variability in how the seals use the beach. They might come for that single bout, they might come for 2 bouts, or they might just be observed for a day. Maybe they were there for a couple more days because we only surveyed once a week, but only coming back to the colony for a few days to then go back out doesn't make a lot of sense. If we look at the spring season, overwhelmingly, the seals are coming back and they're spending a certain amount of time. They're not coming and going. They're not showing up for a day unless they're in that young age group. And that was the only ones that showed that pattern. So what we're seeing is spring season, they have a goal. They're coming to the beach to molt. They can't do it in a day, and they shouldn't come back and forth during that process. Whereas the fall, they have all kinds of flexibility. And we're also still seeing that young age group in both seasons is still showing a ton of variability in how they utilize a colony. So it shows that potentially as these seals reach age 2, they might be maturing enough that they know how to start to get into that adult pattern, whereas those young animals are still in that exploratory phase where they haven't solidified exactly how they're going to utilize their time on land. So objective 3, looking at the movement strategies. So how does the seal from Año Nuevo make its way up to the King Range? What we found is the vast majority of the seals showed the pattern in this animation that I'm going to show you as an example. So 241 seals followed the pattern of PV217. The seal was weaned in 2019 from Point Reyes. They headed out on their first feeding season. They came to the King Range for their first resting haul out. They left for their second feeding season and then came back to the King Range for their first molting season. And these tracks are not based on GPS data. They were just something for me to utilize to better tell the story. But it is the general direction that the juveniles go in when they leave the colony. But this is showing you that at least most of the seals that disperse to the King Range have only been seen there after leaving their natal site. That could have just been for one season. That could have been for multiple consecutive seasons if they survived. But this is the common strategy that we see. That's not the only strategy though. 6 seals exhibited this pattern of PV494. Another seal weaned in 2019 from Point Reyes. They left for their first feeding season, came to the King Range for their first resting haul out, left for their second feeding season, went back to Point Reyes for their first molting season. So not all dispersal is permanent for these young animals. They may make a choice to explore and then go back to where they were born because they didn't like that new spot nearly as much. And this has occurred in both Point Reyes and Año Nuevo seals. This next strategy of 6 seals following this, PV850, weaned in 2020 from its natal site at Point Reyes, headed out on its first feeding season, came to the King Range for its first resting haul out, left for its second feeding season, and went to Año Nuevo for its first molting season. So seals utilizing multiple colonies or checking out multiple colonies between those different dispersal events is possible. These seals might be even more exploratory than we already know. But the hard part is not everybody's out on the beach all the time to the same degree that is being conducted at the King Range, Point Reyes, and Año Nuevo. And then the last movement strategy, 2 seals we observed this in. A seal from Año Nuevo is our example, GE460. She left Año Nuevo and weaned in 2018, headed out for her first feeding season, came back to Año Nuevo for her first resting haul out, headed out for the second feeding season, and then came to the King Range for her first molting season. So this is that example of a seal that waited to explore or disperse until their second dispersal event during their first year of life. So they don't all follow the exact same pattern. There is a lot of variability in what these guys do at sea. If we're going and looking at our natal seals, so the seals born at the King Range, what have they been doing? All the seals we were just looking at were seals that were dispersing from another colony to the King Range. So what we've seen in that 77 juveniles that has been documented again after leaving the King Range colony are essentially seals that have survived their first feeding season. 95% have come back to the King Range. Only 5% have gone to other places, 2 of which were colonies, 2 of which were just public beaches where they were observed. They were only observed once. I don't know if their strategy failed them and they went to a dangerous spot, but we haven't seen them since, and they haven't come back to the King Range. So this tells us, at least for right now, there's not a lot of motivation for these young animals at this small colony to disperse to other places. That is to say that there's only a small number that have been tagged compared to the large number that are tagged at Point Reyes and Año Nuevo every year. So as we tag more of these animals, we might get a different picture. But we still have not seen a King Range seal at Año Nuevo yet. Only one's gone to Point Reyes. So wrapping up this part, what we're seeing is that juvenile elephant seals are dispersing primarily at age 0, that first dispersal event opportunity, or during their first year of life. That spring molting season is a physiologically intense period that results in more of a rigid arrival date and 10-year pattern across all ages of juveniles. They're coming to spring with a purpose. If they happen to disperse during that time, we don't know the reason actually, but less are doing that exploratory movement during the spring. The fall resting haul out season is a flexible season, giving juveniles that freedom to prospect, not just maybe at the King Range, but for all we know, they could potentially be coming to the King Range in the spring or in the early fall and going to Año Nuevo in the late fall. So these animals have the flexibility to pop around to different sites in the fall. Juveniles under the age of 2 are showing more variability in how they visit and use a colony. So those young animals is potentially a really important time period for exploration, for learning, and for forming new colonies, if they're the important ones to do it. But once they hit age 2, they might be really starting to solidify into, okay, this is where I'm going to be as an adult. Juveniles prospect primarily during their first year of life, and their movement can be to 1 or more colonies. It's not a one-size-fits-all strategy. And there are seals that have bopped around to multiple colonies that are doing really well back at Año Nuevo now. So in summary, the King Range colony provides the first example of really successful range expansion of this species north of Point Reyes, or north of that quote unquote historic range. And we hope to see them continue to be successful over time. The main driver of colony growth is immigration at this stage of the King Range's development. As we have more babies born that reach maturity and adulthood, they likely will take over the growth cycle in time. Pup production is continuing to climb every year as immigrant juveniles transition into adulthood. We're really lucky in the last 2 years to have seen, juvenile females utilize the colony as a juvenile and then see their first successful pupping year at the King Range. So it'll be really exciting to get a couple more years of data to really see what the recruitment rates are of those juvenile females if they actually stick to the King Range at adulthood. As the King Range colony continues to grow, it'll likely become an important seed colony for potential new breeding sites between Northern California and British Columbia. The current sites, and this could be limited by habitat too, but maybe having a bigger colony closer to that end of the range will help those Washington or Oregon sites grow. So future implications of this work, climate change is a huge factor. As we've seen this year, specifically as it pertains to warming air temperatures, it was a hot breeding season at Año Nuevo. This site, specifically in reference to seals down in Mexico, is obviously a lot cooler latitude. So we're likely to see seals need to kind of reshift where they're distributed, and they might start redistributing north So this colony could be a refuge for seals being displaced because of those temperature differences. Also, seals being displaced by sea level rise, especially at Piedras Blancas, potentially at Point Reyes. This site currently still has upland habitat that the elephant seals could utilize if sea level rise does impact this site too. Management, so this colony continues to grow and seals move because of habitat changes. So this colony is currently growing and these seals are going to utilize more habitat. They're already sitting on the trail. So the BLM management team already has their hands full with human interactions, but as the colony grows, that's just going to become more of a challenge. And as climate change impacts the redistribution of these animals, that's going to impact management everywhere. Seals are going to end up in more parking lots or on more public beaches that people want to utilize, but can no longer do so at certain times of the year. And then lastly, the biological importance of this study. So this really confirms and affirms the results found in studies done at the Farallones that juveniles really are the ones driving colonization of new sites. And they're playing a very key role in dispersal. This also shows the importance of that fall resting haul out season. We know that there's importance during that breeding season to protect seals. We know there's importance to not cause disturbance during the molting season because they're utilizing a lot of energy. But there's also importance to that fall season to not disturb those juveniles, especially at potentially new growing sites. If those animals are scared off of a site, that site might not continue to grow. So this is kind of helping to confirm that elephant seals should be heavily protected all year round at their sites. Lastly, just acknowledging all the different collaborators and supporters. Obviously, Cal Poly Humboldt, which was my where my graduate work was conducted and who funded a lot of my work. The Bureau of Land Management for letting us do this project on their land, as well as funding a lot of our research. Coast, that's affiliated with the Cal State system, also through funding, National Park Service, UC Santa Cruz, and Point Blue for all collaborating on sharing that elephant seal data so that I could know where these seals went after they went to the King Range. So these studies are so collaborative, and it's so important to communicate with each other, because studies like these on seals going hundreds of miles all over the coastline can't be done without people talking to each other. All right. That's all I'm going to say. I'm sure there's questions. I'm going to stop sharing for now just so I can see you guys, but I can reshare slides if you have a specific question.
So there's several questions in the chat, and I don't know if it'd be, I don't know if you can see them or if you want me to read them to you. But before we get onto those questions, we love having slides of any presentation. I don't know if you're able to send us the slides at some point. And then I just wanted to say nice graphics. I'm sure you worked on making a lot of those animations and everything, or the maps. So thank you so much. Do you want me to read these out loud, or do you want to read them out loud? I don't know if everybody can see them. So
I can see them now. Where is the other blue tag located? Great question, Faye. Vandenberg Air Force Base down near Point Conception. The problem is those seals can overlap with each other. And one seal from Vandenberg has come to Año Nuevo. So hopefully we don't ever put out the same tag numbers. But we do know who's doing that, so hopefully we can prevent that. They do also put out blue tags in Mexico, but it's an extremely rare occurrence that Mexico seals would make it up to the King Range for at least landing on land. what do you think the double bout might mean that they're going to other colonies in between? They're going to other colonies in between. So, Judy, can you clarify that question? If you're still with us.
Sorry, I was muted. So what I was wondering was whether they were perhaps exploring other colonies when they left the King colony and then they came back. Whether
they could have. I think, and this is something that we talked to one of the researchers at Año Nuevo about this too. And they have seen some juveniles do it at Año Nuevo as well. I think it might be more so that they're coming early to the molting season, or not molting season, the resting season. They leave for another feeding trip. And I don't know if that means a shorter feeding trip. And then they come back again, not realizing that they're early to molting season. Or I don't know if there's a benefit to haul out twice for these guys, if there's a social aspect to the fall haul out that they might felt like they have missed by coming too early. That fall season has a lot of debate on whether it's they need to be on land to maintain their bone density. Do they need to be on land to socialize? Do they need to be on land to lose some weight because they get too buoyant if they eat too much for too long? So there's a lot of questions on why do some seals pop around or kind of stick to this really solid, I come and I go, and it's only once. So it was a pretty small sample size for seals that did that come and go double bout pattern. But I think more data over time will give us maybe a little bit more answers. And it would be awesome to put a satellite tag on one of those seals, but I do think that they lose that pattern as they get older. So you might not be able, you might just have to opportunistically catch that.